tan x, if you take it as f of x, then f dash of x is secant square x. So clearly f of x is tan x and f dash of x is secant square x. It is the same integral for what you have learned, but one extra thing is you have to divide it by 1 by a. The function and its derivative will be inside the integral only, so we can recognize which function we can take for the substitution. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am, Vidhyaashram School of Excellence, Mysuru. In our previous session, we have studied how to find out the integration by inspection method. Now we are already familiar that if we know the derivative of a function and its derivative, it is easy to find out the integration. So here we have a method called integration by substitution. That is, we will be finding the integral values when we have its function along with its derivative. So what is integration by substitution? So it is suitable for the integrand. For integrand means the function which is inside the integral f of x. So that is integrand, function and its derivative form. So this method of substitution is suitable for a function and its derivative form. Whenever the function as well as its derivative are both inside the integral, then this method is suitable. So what are the types of this function and derivative forms we can see here? This is the function where it can exist. So a function can be repeated n times and its derivative is also given. So that is what dx. For example, I can take what is integration of tan x secant square x dx. So clearly you can see tan x, if you take it as f of x, then f dash of x is secant square x. So clearly f of x is tan x and f dash of x is secant square x. Then how to find out? So this is again we take some u is equal to tan x. So then when you derive it, du is equal to secant square x dx. So now just replace this with respect to u. We have taken tan x as u. And here we got secant square x dx as du. So replace it. Now integrate it. What is integral of x into dx? It is x square by 2 plus c. Similarly for any other parameters also, whenever you have u with respect to du, this will be u square by 2 plus c. What is u we have taken? It is tan x. So therefore this becomes tan square x divided by 2 plus c. So this is nothing but the method of substitution. We'll substitute any function with any other parameter and we will find out its derivative which is inside the integral only. We will convert it into any one of the standard forms where we have studied all the standard integrals, and then we will integrate it and write the integration constant. So this is one type. The another type is the derivative may be in the numerator and the function may be in the denominator. So these are the two forms of integrand where function and derivative exist in integral. So let's see some of the standard integral. Suppose you have any function in the form of ax plus b, then you have to write its derivative in the form of ax plus b divided by a. For example, if you have sine 3x plus 7. So these are all some important integrals. You can just remember to write it. So when you have a function in the form of ax plus b, the derivative will be in the form of 1 by a. So here a is nothing but 3, b is nothing but, so this is b here, b is 7 here. So therefore ax plus b means this is 1 by 3. So integral of sine 3x plus 7 into dx can be written as 1 by 3. What is integral of sine? It is cos ax plus b plus c. So here ax plus b is nothing but 3x plus 7. So this is how we are going to write. Suppose you have e power 4x plus 7. When you are integrating with respect to dx. So e power 4x plus 7 means what is integral of e power x? It is e power x only. So but this is in the form of ax plus b. Whenever any function is in the form of ax plus b, it is 1 by a times the integral value. So therefore here it becomes 1 by 4 times e power 4x plus 7 plus c. Similarly, if you have any secant ax plus b tan ax plus b into dx. What is the integral of secant x into tan x? It is secant x. So therefore it is secant ax plus b. Since you have the function in the form of ax plus b, you have to divide it by 1 by a plus c. So this is how you are going to convert any function in the form of ax plus b. It is the same integral for what you have learned, but one extra thing is you have to divide it by 1 by a. Let me take integral of cos 2x. So cos 2x means here you have only ax, you don't have b. So nothing worry here. So we need only the value of a to divide it. So therefore it is 1 by 2 times sin 2x plus c. So what is the integral of cos x? It is nothing but sin x. But since we have here 2x in the form of ax plus b divided. So when you have sin x, so this is minus cos 3x plus 7 plus c. So like this, any function in the form of f of ax plus b, you have to write its derivative as it is where you have learned the standard integral. Only thing is you have to divide it by 1 by a. So now I hope you understood the first one. Next we have second one. So this is what we have discussed previously. So the function with respect to its derivative. So where we are going to apply the method of substitution. Here also the function with respect to its derivative. So here n represents the number of times the given function is repeated. So whenever these forms exist, I can write the answer as log f of x plus c whenever the function and its derivative is in product form, and whenever it is in the quotient form, I can write it in the form of f of x to the power n plus 1 divided by n plus 1 plus c, where c is the integral constant. So I can take an example of here integral of sin square x cos x dx. So sin square x cos x dx. So here we can see here, put t is equal to sin x. Derive it. So what is dt? dt is cos x dx. So substitute here. So this becomes integral of, so cos x dx can be replaced with dt and sin x can be taken as t square. So what is the integral of x to the power n dx? This is in the form of x to the power n plus 1 divided by n plus 1 plus c. So similarly for t with respect to dt, it is t to the power 2 plus 1 3 divided by 2 plus 1 3 plus c. So what is t we have taken? T we have taken as sin. So therefore I can write it as sin cube x divided by 3 plus c. So this is the integral of the given function. So this is how we are going to find its derivative. So these are the some standard forms where you can remember, that is using the substitution method we can find the integral of some function. So let's move on to the first question. Integrate the following with respect to x. First one, integral of cos 3x dx. So we have to find the integral of cos 3x. So I already said that any function in the form of ax plus b is nothing but 1 by a times the integral of ax plus b. Here phi represents the integral value of function. Suppose if you have sin x, what is integral of sin x? Integral of sin x is minus cos x. If you have secant square x, what is integral of secant square x? It is tan. But if you have in the form of ax plus b, you have to write that also in the form of ax plus b divided by 1 by a. Now here we have integral of cos 3x. So therefore here, what is integral of cos 3x? Integral of cos 3x is nothing but sin 3x. But since you have 3x here, you have to take it as 1 by 3 plus c. So these are all very simple 1 mark problems. Next, e power 2x plus 3. Again, this is in the form of e power ax plus b. So here the value of a is 2. I can clearly write it as 1 by 2 times e power 2x plus 3 plus c. Because integral of e power x is e power x only. Now e power ax plus b is 1 by a times e power ax plus b. Next, secant square 7 minus 4x. Remember, this is minus 4x means here the value of a is minus 4. So therefore here, what is integral of secant square? It is tan x. So therefore it is tan 7 minus 4x plus c. But here the value of a is minus 4. It is minus 1 by 4 is the answer. Next, tan square 2x minus 3. We doesn't know the standard integral for tan square, but we can reduce tan square in the form of secant square 2x minus 3 minus 1. So using the standard formula, that is 1 plus tan square theta is secant square theta. Hence, secant square theta minus 1 will become tan square theta. Now, we have two functions. Apply the integral separately. So, it becomes secant square 2x minus 3 into dx minus integral of 1 into dx. So, what is secant square integral? It is tan. So, therefore, it is tan 2x minus 3. But this is in the form of ax plus b or ax minus b. You have to divide it by 1 divided by a. So, it is 1 by 2 minus, what is integral of dx? It is x plus c is the integral constant. Next, we have integral of cot x into log of sin x dx. So, here we will just use the simple method here. So, what is put log of sin x is equal to t. So, now we have two different parameters. So, let's differentiate on both sides. So, what is derivative of log of any function? It is 1 by x form. So, derivative of log x is 1 by x. So, therefore, here log of sin x is 1 divided by sin x. Again, sin x is one more function. What is the derivative of sin x? It is cos x into dx. Because here parameter x, we are going to write dx, and here we are going to write dt. So, therefore, cos x by sin x can be written as cot x dx, which is equal to dt. Now, replace back to the function. This is equal to cot x dx can be written as dt, and log of sin x can be written as t. Now, what is integral of t with respect to dt? It is t square divided by 2 plus c, which is nothing but, what is the value of t? We have taken log sin x. So, therefore, this can be written as log of sin x whole square divided by 2 plus c. So, this is the integral value of the given function. So, here making use of substitution, we are going to substitute log sin x as some other parameter. Next, integral of cos 6x square root of 1 plus sin 6x dx. So, here put 1 plus sin 6x is equal to some t. Now, derive it. Derive it, this is 0. So, derivative of sin 6x is cos 6x into derivative of 6x is 6. So, using chain rule. So, derivative of sin 6x is cos 6x, and again 6x is one more function. When you derive it, it is 6x. dx is equal to dt. So, now here I need only cos 6x into dx because I don't have any 6 here. So, let me take this as dt divided by 6. So, now here replace cos 6x dx, cos 6x into dx with dt by 6. So, this becomes dt divided by 6, and here it is 1 plus sin 6x as t. So, this becomes root t. Take 6 outside because it is a constant. We know from the property of the integrals, whenever you have constant inside the integral, take it out of the integral. So, it is 1 by 6 integral of root t dt. So, root t is nothing but t to the power half. So, I can write it as 1 by 6 t to the power half plus 1 by half plus 1 plus c, which is nothing but 1 by 6 times. So, half plus 1 is nothing but t to the power 3 by 2 divided by 3 by 2. So, here I can cancel 2 1s are 2 3s are. So, this becomes 1 by 9 times t to the power 3 by 2 plus c. But what is t we have taken? We have taken t as 1 plus sin 6x. So, therefore, the answer is 1 divided by 9, 1 plus sine 6x to the power 3 by 2 plus c. So once you have taken other parameter, then again replace back to the original function after getting it into the standard form. Next, tan power 4 root x secant square root x divided by root x into dx. So here put root x is equal to some t. Then derive this. What happens? Derivative of root x is 1 by root x into dx is equal to dt. So here 1 by root x dx I have. So 1 by root x dx can be written as 2 into dt. Now replace back here, it happens. So 1 by root x into dx can be written as 2 into dt. Tan root x become tan to the power 4t secant square t, and here we have 2 dt, so I'll write 2 here, dt here. Let me take 2 outside, then it becomes tan power 4 t secant square t dt. Next, after this, I'll take one more parameter here. So here what I will do here, put tan t is equal to some u. Another parameter, put tan t is equal to some u. Then what happens? What is derivative of tan? It is secant square. So secant square t dt is equal to du. Again replace back. So you can take 2 outside, integral. I have taken tan t as u. Here I have tan 4 times. So therefore it becomes u to the power 4. Next, secant square t dt can be replaced as du. So what happens now? 2 times. What is integral of u power 4? It is u power 5 divided by 5 plus c. Now here 2 times. What is u we have taken? U we have taken as tan t. So therefore it is tan power 5. Here I have to take as t. 5 I will write here, 2 by 5 plus c. But I have a replacement for t also. I have taken t as root x. So therefore the answer is 2 by 5 tan power 5 root x plus c. So this is the final result. So thus the integration of this function is 2 by 5 times tan power 5 root x plus c. Next question. E to the power tan inverse x divided by 1 plus tan x square. Clearly, the function and its derivative will be inside the integral only. So, we can recognize which function we can take for the substitution. Now, here put tan inverse x as t. Then what is derivative of tan inverse? It is 1 by 1 plus x square into dx is equal to dt. Now just replace it back. Integral of e power t, and this function can be taken as dt. What is integral of e power t? It is e power t plus c. But what is t we have taken? We have taken t as tan inverse x. So therefore the answer is e power tan inverse x plus c. So this is the function whose derivative is given. Next, integral of 2x sine x square plus 1 dx. So here we have 2x, here we have x square plus 1. So we need only algebraic here. So we take put x square plus 1 is equal to t. What is derivative of x square? It is 2x. What is derivative of 1? It is 0. Derivative with respect to x, and t will become dt. So you can take 2x dx as dt, sine x square plus 1 as t. So we will get sine t dt. What is integral of sine t? It is minus cos t plus c. But what is t? T we have taken as x square plus 1 plus c. So when you derive this function, you will get back same 2x into sine x square plus 1. That is why here always the derivative is given whose function has to be found. Next, cos x divided by 1 plus sine x. Put 1 plus sin x is equal to t. What is derivative of sine? It is cos. So cos x dx is equal to dt. So now here we have integral of, so cos x dx can be written as dt divided by t. So now this is in the form of 1 divided by t into dt. So we know that integral of 1 by x is log x. So therefore I can write this as log of t plus c. But what is t? Log of 1 plus sin x plus c. Next one, 1 over x plus x log x into dx. So here integral, in the denominator x is the common factor. So let me take x as the common factor, then it becomes 1 plus log x into dx. So now put 1 plus log x is equal to some t, derive it. Derivative of 1 is 0, derivative of log x is 1 by x with respect to dx, derivative of t is dt. Now look here, dx 1 by x or 1 by x into dx I will replace as dt. So therefore I'll get here dt divided by 1 plus log x I have taken as t. So this becomes log t plus c. But what is t I have taken? 1 plus log x. So therefore this is log of 1 plus log x plus c. Next one, root tan x divided by sin x into cos x. So here I'll write the numerator as it is, and in the denominator I will multiply cos x and divide by cos x. So into dx. Now here what happens? Cos x into cos x is cos square x. So here it is tan x divided by sin by cos is tan. So this is tan x into cos square x into dx. So when you have anything like root x by x, so this is nothing but x can be written as root x into root x. So cancels. I can write it as 1 by root x. So therefore when you have root tan x by tan x, I can write this as, so 1 divided by root tan x. So here I have cos square x dx. What is 1 by cos x? It is secant x. So then 1 by cos square x can be written as secant square x. So therefore this becomes integral of secant square x divided by root tan x into dx. So now just after simplification, you can use the method of substitutions. So whenever any sort of trigonometric functions are given, sometimes we have to simplify it to make a part of substitution, and then we will reduce it into standard form. Again, we will write the function in the form of x only. So now here put tan x is equal to t. Then what is tan x derivative? It is secant square dx is equal to dt. So the numerator secant square dx can be replaced with dt, and denominator can be written as root t. So root t is nothing but t to the power minus half. So t to the power minus half into dt. So 1 by root t or 1 by root x with respect to dx. So is nothing but 2 root x plus c. So this is one of the standard integral we have learned. So here also you can directly write this as 2 root t plus c, or you can use the simplification t to the power minus half plus 1 divided by minus half plus 1, which is nothing but t to the power half divided by half, which is nothing but 2 root t, which is one and the same. So any method you can use. So this is using the general formula, and this is using standard integral. So anything in the form of 1 by root x can be written directly as 2 root x. So therefore 1 by root t can be written as 2 root t plus c. But what is t we have taken? T we have taken as tan x. So therefore it is 2 times root tan x plus c. So this is how we are going to solve any sort of functions using substitution method. So we will take up few more problems in our next session. Until then, keep watching, keep learning, keep exploring. Thank you.